In this tutorial, we'll walk through how you can apply a set of rules to this cactus. By the end, your model will be able to morph from a small round barrel to a tall saguaro-like cactus with arms, and infinite options in between. You can find the starter model and the code outline in the description below, as well as the finished model if you'd like to take a look around. If you haven't already seen our tutorial on the basics of rules, I'd recommend that you check that out first to get familiar with scripting in SpeedTree. Alright, let's jump in. You can use the built-in editor in the SpeedTree modeler, or you can use another coding environment and copy and paste back and forth. I'm going to do that, and I'll be using Visual Studio Code. Okay, let's start scripting. To get started, I've already written the randomize rule for you, so let's copy and paste that in. Perfect. Okay, let's write the height rule next. If you're already familiar with scripting and want to take a stab, pause the video and try it out on your own. Okay. I'm going to go ahead and get an idea of what I want my min and max values to be for my height. So I'll be using spine length absolute. I think I'll go with 1.5 and 6. I'm working in feet, by the way. While I'm here, I can go ahead and right-click on the property and click Copy Edit Line for Script to paste into my rule body. I'm going to pull up my script and write my definition. Now, we need to put in our default min and max value for our slider. For the default value, any number between 0 and 1 will be fine. Our min and max will be 0.0 and 1.0 because we're creating a rule that uses float values. Okay. Then I can write to the body of my rule. We'll paste in the line that we copied. We'll write a variable to hold our interpolate value. Then we'll use the math.lerp function and plug in our min and max that we chose. And we'll pass in our rule name. Lastly, we just need to swap out the placeholder for our variable name. Then we can copy and paste. And it looks like my slider is working. Great. Okay, let's do a quick save. Next, let's write our width and straightness rules. So the width rule will control the overall radius of the cactus, and the straightness rule slides the silhouette between a rounded silhouette and a straight silhouette. So for both rules, I'm going to be modifying the skin absolute radius property. Now it's important to remember that the last rule to use a property wins. So you have to be careful not to accidentally double dip on your properties. However, what I'm going to do here is for the width rule, I'm going to modify the numerical value of the property. And for the straightness rule, I'm going to modify the profile curve. You can treat the numerical value and the curve essentially as their own separate properties. So this won't cause a conflict. We'll speed through the width since it's pretty standard. So choose the min and max values, write the definition, and write the body. Then, while we're here, I'm going to copy the profile curve for our straightness rule body. We'll need each curve to have a unique name. So you could do curve A, curve B. I'm going to refactor this one to be curve straight. Then we'll make our rounded profile curve. I want my rules to be capable of generating a small barrel cactus. So I'm going to scale down the height and adjust the radius values to help inform what profile curve I should choose for my script. Okay, I like how that looks. So I'll copy and paste and rename it curve round. Then we write our set statement, which will use set property profile, since we're modifying a profile curve. To set our final value, we'll use the function lerp curve to curve and pass in our curves. Since our rule is named straightness, When the slider is at 1, I want that to be the straight profile. So I'll put curve round first and curve straight second in my lerp. Lastly, we'll pass in our rule name. Now we'll write our straightness definition. I'll just set it to default to 0.5 for now, because I can always change it later. Okay, let's copy and paste both of those into the modeler. Everything looks like it works. And now we can get a range of different bodies for our cactus. Hooray! All right, we're going to take a pause from the main body and move to the flower section. First, let's write our flower color rule. This will introduce a new concept. So for this rule, we will need to swap the material our flower petals are using. In the Material tab, you'll see that we have 3 colors: red, yellow, and pink. Then, if we go to the Material tab on our main petal generator, you'll see that each material has this index number. This index pops up when you enable rules for the first time on a model. So what does this index tell us? Well, when you create a material in the material bar, it assigns an index for the lifetime of that material. That won't change. So even if you reorganize your materials or delete something, the index of any given material will always be constant. We'll reference the indices in our rule when swapping materials. Okay, let's write our flower color definition. For this rule, we're going to use a new type called rule combo. Rule combo will create a drop-down box with whatever options you specify. We'll add our header and name. Next, rule combo calls for a table of strings. These strings are what will be displayed in our combo box. So in our case, that will be our different color names. So what we can do is create a table of the colors we're going to have, and I'll call it something like flower colors. Then I'll add red, yellow, and pink. Using a separate table up here is optional, but I like it to keep everything organized and add more colors later. Right now, I can pass the flower colors table into my rule definition and paste the script into the modeler. Now, as you can see, we have a drop-down with our color names. Okay, let's work on the body of the rule. We can first go to the main flower petal generator's material property and copy edit line for script. Next, we'll need to pass in the correct material index to the set statement. So I'll make a variable. Then we'll need a way to link together the indices from the drop-down menu to the correct material index. To keep things organized, I'm going to create another table in the configuration section with the material indices that match our colors. And I'm going to match the order of the names in the previous table. So we had red, yellow, pink, and that will correspond to 9, 17, and 18. Just note that your numbers might be different if you moved anything around. Next, back in our rule body, we can call that table. To get the correct material index, what we'll need is the index of the drop-down item that is currently selected on our rules dialog. So where do we get that number from? That number is stored in the flower color rule variable. Okay, next, let's tackle the flower size rule. This should be pretty straightforward since we just need to change the size of our petals. But if we select both the main and small petals at the same time, we see that we can't scale them at the same time to find our min and max because they aren't scaling proportionally to each other. So let's first find the min and max size for our main petals. So I think I'll go from maybe 0.12 to 0.45. Then I'll write the set value function for the main petals. Now, when I paste that into the modeler, I can slide the slider to 0 and adjust my small petals to find the appropriate minimum. And I can do the same thing for the max by sliding to 1. Okay, update the script with those values, copy and paste into the modeler, and the petals scale correctly. Now, as you're working, it's always a good idea to play around with the rules you've already written to make sure that everything is interacting together well and that nothing unexpected is happening. So far, everything looks good, but can you see it? Something is happening with the height rule. It's very subtle, but when I increase the height, the flower is sinking into the model. So you can see it better, if I adjust the original first and last values, it becomes even more pronounced. So what we can do to make sure our flower stays in place is to make our first and last boundaries set to the same number. For now, I'll set them both to 1. Then, so that the flower isn't sitting so far up above our model, we can substitute the sink property to adjust the placement of the flower's base. Once I've done that, I can adjust the height and the flower stays in the same spot. So it's important to keep in mind that as you're writing rules, you might need to make some adjustments to your base model as you go along. Okay, last for the flowers, let's write the num flowers rule. I want to be able to create a ring like this. Here we will use rule int. This will create a thumb wheel instead of a slider. I'll set my default to 1 and my min to 0. But I don't really know what I want my max to be right now, so I can leave that off for now. I'll paste what I have into the modeler, and there's my integer thumb wheel. Next, we'll need to set up our flower generators to work with either a single or multiple flowers. Because I know I'm going to play around with my settings a good bit, I'm going to make a copy of my original flower generators for safekeeping on the side. Now, if I try to increase the number of flowers, I'm going to find pretty quickly that they all stay in the center and don't spread out in a ring like my reference photo. Even if I try to change the boundaries, it still doesn't work. So what I can do is go to the Skin tab and enable welding. Now, you might get a warning that the weld failed. To fix this, simply adjust the boundaries in the Gen tab to be a little lower. And fantastic! Our flowers show up. Just remember to set the first and last boundaries to be the same number to combat any shifting. Now, I'm just going to scale down the flowers so that I can see a little better, refine some base settings like start angle, and I'll test out increasing the per step number. Okay, now we can see that this will work when we want multiple flowers in a ring. But when I want a single flower, I'll want my generator's original settings. Since I changed a lot of settings, the easiest way to switch between single and multiple flowers will be to have 2 sets of generators and show the appropriate set and hide the other set. So what I'm going to do is attach the generators I copied back to my model and rename its flower base generator to something like flower base single. And the generator that will handle multiple flowers, I'll name flower base multi. Now for the multi-flower base, I'm going to be increasing and decreasing the number of flowers, so I'll need a set value line. So I'll just grab the edit line from the per step number property and paste it into the script. Then we simply need to write a conditional statement to hide and show the right set of flower generators. So first, when num_flowers is equal to 1, we want to show the flower base single generator and its children. For this, we're going to use another function called setVisible. SetVisible takes two Boolean values. The first Boolean controls whether the parent generator is visible. So here, I'll put true. The second Boolean is optional and states whether the visibility of the children should match the visibility of the parent. In this case, for the petals attached to flower base single, that is true, because we want the parent and children to show up at the same time. Following that logic, we can write the setVisible line for our flower base multi-generator, and our first argument will be false, but our second argument will be true, because it's true that we want the children to match the visibility of the parent. Okay, then we reverse everything in our else statement. I think I'll also go ahead and update my max value in my definition to 12. And copy-paste into the modeler. And we see our generators show and hide appropriately. As a quick aside, if you want fewer lines of code, you can opt to write your conditional statements like this. Now, there's one thing we need to fix. If you'll notice, when our flower count goes to 1, we see that the size is bigger than when we have 2 or more flowers. So what's causing this? Well, if we look at our script, there's an equal sign in front of the main petals and small petal strings. The equal sign means the script will act on generators that match that string exactly. What happened before is when we copied and pasted our generators, the modeler appended numbers to make them unique. So what we need to do is remove the equal sign, and now it will act on any generator with that string in its name. Okay, that's fixed. I'm just going to test out the rest of the rules. We have an inconsistency when we switch the color. But once again, the fix is simple. We just need to remove the equal sign in front of main petals in the flower color rule. Okay, I'm just checking everything one more time. Looks good. I'll reset to the defaults. Now let's write the rule to adjust the number of ridges of the cactus. To write this rule, we first need to know a bit more about how our model is constructed. The ridges of the cactus are created by a displacement map in the Displacement tab, coupled with the U value in the UV tab. So you can increase or decrease the number of ridges with the U property. In addition, it's important to note that we also need to update the count property on the needle generators so they equal the number of ridges. So I can write the rule as normal, pasting in my edit line and writing my definition using rule_int. Also, we have to make sure that our needle generators update to align with the ridges. So we will want to go back to our rule body and add a setValue call for the needle's count property. Then we paste into the modeler, and it looks like the ridges and the needles are both increasing and decreasing, but we can see that something isn't quite right. When the number of ridges is odd, the needles are offset from the ridges. If I check in the UV tab, I can see that I have some offset already applied. If we change the U to an odd number, And actually, I'm going to do it from the rules dialog so that the needles also update. If we then change the offset to 0, then the needles line up. So this tells us that we need our script to update our UV offset based on the number of ridges, whether they're even or odd. I'll copy the edit line and paste into the rule body. Then I'm going to opt to make some constants at the top of my configuration section. So I'll make UV offset odd equals 0 and UV offset even equals 0.5. Next, I'll need to know whether the current number of ridges is odd or even. So I'm just going to write a little helper function that uses the modulus operator and returns the correct constant. Then in our rule body, we'll call the function passing in num ridges. And with all that, we have fixed the misalignment of our needles. Okay, now let's add a little more character to our model with the twist rule. I have some references here, and I personally love how some cactuses twist and twirl. It's so fun. So how can we achieve that similar effect? Well, there is a twist property we can try in the spine tab, but when we bump that up, you can see that it twists more at the top than at the bottom, and we don't have a profile curve with which we can adjust the distribution. So an alternate option is to use the up parent curl property, which does have a profile curve, so we can tune the twist however we want. I want it to be more evenly distributed. Okay, so that looks pretty good, and we can copy edit line for script, then write the rule definition, and here's the body. Now let's test. Okay, looks good to start. Now let's test how it interacts with the other rules. And it looks like when our model is short, the twist is pretty extreme. So because the height is affecting how our twist looks, what we need to do now is adjust the amount of twist that is applied relative to our height rule, meaning that we want to reduce our maximum twist as the model gets shorter. We could lerp the base value, or we could adjust the profile curve. I'm going to opt to use the curve. So to do that, first I'm going to set my height to 1 and determine the max curve I want when height is at 1. So there's the max, and I'll name the curve curve max. And then I'll slide my height rule to 0 and find the curve that I want to be the max amount of twist when my height is at 0. If I want my amount of twist to be proportional from my minimum height to my maximum height, I can simply see by what factor my absolute property increases and use that to inform my curve. So my minimum absolute length is 1.5, and my max was 6. That's an increase by a factor of 4. Therefore, I can reduce my curve by dividing by 4. So my y will go from 0.4, the base value of parent curl, to 0.1. And that level of twist looks good to me. Right, copy and paste that to the script, and I'll call it curve min. Then we will use set property profile and call lerp curved curve. But here, instead of passing in twist, we'll pass in the height rule variable so that it lerps relative to height. And when we paste into our script, we can see that it indeed creates a nice smooth twist as we scrub our height slider. Now, the one downside to this method is that it is causing some stretching to our needle texture when twist is high. To counteract this, we can add a few lines of code that will adjust the X value of the needles, which we can find in the Geometry tab. That looks better. All right, we've got 2 more rules to write in our main body section. Let's do noise next. I want to allow the model to have a bit of wiggliness, like this. For that, I'm going to use the late noise property. Okay, I'll write my definition, then the body of the rule, and I'll go for a max value of 0.7. Then paste in the script. Okay, now moving on, I've left the shape rule for last. When we wrote the straightness rule, we made a slider that would take the model from a straight body to a curved silhouette. But we don't have to stop there. We can write a rule that will allow us to change the base shape of our model by modifying the skin profile curve. That way we can have a range of shapes for our model when straightness is less than 1. So to do this, let's start by writing our definition. Once again, we'll use rule combo. That means we'll need a table of strings that will be the display names of our shapes. Do you remember how we did that for flower colors? We'll do a similar thing. So we'll want to end up having a table called something like shape display names. Now, besides the display name, we'll also need to store the profile curve for each shape. So what I'm going to do is make a table for each shape to store its data. So for my first shape, I'm just going to call it shape default. Then I'll make a variable for the display name. I'm going to call it round. Now notice that these names don't have to match. Then I'll add a field for its profile curve. I'm going to go grab that curve that we used earlier from the straightness rule, curve round. Now, within tables, curves need to be formatted in a particular way for Lua to work with them. So we need to remove curve round from all lines but the first. If you want to refactor it all in one go, you can use this string of regex characters. And we need to add commas after each bracket, except for the last one. I'm also going to refactor the name of the curve variable. Okay, so now we can create some other shapes. For the next one, I'm going to name the table shape 1 and the display name bottom heavy, and I'll use the shape that I currently have. You could make the names match, but I'm just going to call it shape 1 for flexibility in case I wanted to change the profile curve later. Then I'll make shape 2, and I'll call the display name top heavy. Then I'll adjust the profile curve and format it in the script. I'm going to stop there, but you can make as many shapes as you like. Next, we need a table that acts like a list of all the shapes. So I'll make one called shape list that has shape default, shape 1, and shape 2. We'll also want to make a table with our shape display names. This is the table that we will pass into our rule definition down here. Now, I'd also like to be able to add or remove shapes. So to make this a little bit more robust, we can write a helper function to run through shape list and extract all the display names for us. So I'll write a function called extract display names, and I'll pass in the list of shapes. Then I'll write a loop that will extract the display name from each shape in the table and insert them into a new table, which will be returned at the end of the function. Then I can call that function when I initialize the shape display names table. And with that, shape display names contains the strings which will be passed into the shape rule to create our drop-down menu. Before we copy and paste, I noticed that I forgot some commas after variables in my tables, so I'll just add those, and I'm just going to fix some capitalization as well. With that, I can copy and paste everything into the modeler. Okay, we have our drop-down. But we still need to write the body of the rule in order to actually change our shape. So, back in our code, we can paste in the edit line for script from the skin absolute radius property. Then we want to get the correct shape from shape list. To do that, you might think to write the call like this, but this by itself can actually lead to an indexing error. So while global variables are generally not best practice, since rule scripts are very self-contained, it's usually okay to use them. So I'm going to make a variable called current shape and initialize it with shape default. Then we can just add some guardrails for extra safety. Now we can substitute current shape.curve into our set property call, so it will get the curve table from the current shape. Lastly, make sure to change set property value to set property profile. Oops, I got an error. It looks like I just need to add an underscore here. But even when we fix that error, when we copy and paste all of that into the modeler, our combo box still doesn't function. Why is that? Well, remember that the last rule to update a property wins. So what's happening is the straightness rule wins when calling the skin profile curve. Thankfully, that's a pretty easy fix. The straightness rule body no longer needs curve round because it's held in shape default. So we can delete that, and then in our curve lerp, we can change curve round to current shape.curve. And now we can change the shape of our model with our dropdown. Additionally, we can tune how straight it is with the straightness slider, so we can get an infinite number of shapes. Okay, I'm going to do another quick save. And from here, we're going to speed up a little bit. So, to make this cactus even more versatile, let's add some arms. Now, you can model the arms yourself, but if you'd like to just focus on the rules part of it, you can scroll up in the generation window and you should find some arm generators that I've already made for you. Just drag and attach them to the cactus generator and unhide them by hitting H on your keyboard. Once you've done that, if you want to try writing the rules for the arms yourself, go ahead and pause the video and try that on your own. Okay, so for the randomize rule, it's just like the global randomize, except that we'll pass in the cactus arms generator name instead. Now, for the moment, I'm going to skip the num arms rule and go to length and width. These two are also pretty straightforward. As you're writing them, you may want to adjust the height and width of your cactus body with your rules so that you can choose good universal values for your arms. Next, for the rules to set the arm position and to vary the arm positions, I have choices for which properties I want to use to control the placement. So I can use the first and last boundaries, or I could use the position property. I think I'm going to use the first and last boundary to set the arm position rule. I'll just set them to the same value and make sure that they move up and down together. Then for my rule to vary the arm position, I'll end up using set property variance on the position property. Okay, I'll just write some quick definitions. And for the body, since first and last boundaries typically go between 0 and 1, and my slider is going to go between 0 and 1, I'm going to try skipping the lerp statement for the time being and just pass in arm position directly to set property value. Then for my rule to vary the arm position, I'll use set property variance on the position property. Testing. Okay, they look decent, but we can see our arms are disappearing at the top and the bottom. So I'm going to add in a lerp statement after all to the arm position rule. Let's try 0.035 to 0.955. Okay. That's better, but when we take the height down to 0, we see that we need to constrain our boundaries even more. So let's do something similar to what we did in the twist rule and adjust our max and min first and last boundaries relative to the height. Pause the video if you want to try to figure it out yourself. Okay, so what I can do is make a minimum position variable, then I'll lerp between the minimum first boundary when height is at 0 to the minimum first boundary when height is at 1. So 0.2 will be my first boundary when height is set at 0. I'll choose my first boundary when height is at 1 in a moment. Then I can make a variable to hold the maximum position and do the same process for the last boundary. So when height is at 0, I want my max last property value to be 0.9. Then I'll set height to 1 and find the appropriate min and max values. And I can just use the values I already found before, which was 0.035 and 0.955. Then I can replace my values here with my position min and position max variables. And when we paste that in, you'll see the first and last boundaries are interpolating based on our height. Now I'll go back to write the rule for the number of arms. You might be wondering why I skipped this earlier. Why is that? Well, we'd probably write this with rule int normally, right? But because the rule to vary the arms' positions can push the arms outside of the boundaries of the cactus, the number of arms might not always correspond to the integer displayed by a rule int thumb wheel. So for that reason, I'm opting to use a regular rule slider and call the display name something like arms amount. This way, the rule will be increasing and decreasing the number of arms without being tied to a specific number. However, you can always change your approach. Okay, we can test it out with everything else. And our variance works. Just testing. Okay, things look good. Now is a great time to do another save. Finally, we're in the home stretch. Let's round out this model by making a rule to increase or decrease the amount of polygons. There are so many approaches you could take, but what I'm going to do is first adjust my base segments. For my cactus body, I'm going to set the absolute number of segments to 0, and then write lerp statements for the relative segment properties. Because I want my slider to optimize the model more as I go towards 1, in my lerp statements, I'll put my larger value first, and then my smaller value. I also have a typo here, so be sure to put up math.lerp. And I'll create my other set property statements. I think I'm going to also optimize the flower base generators. Then I'll test out my optimize rule against the other rules. It seems that I need a few more segments when my arms are short, so I'll just bump up the segment length absolute property in the cactus arms. Remember, the absolute segment property is not being modified by my rule. But with that adjustment, things look pretty good. And finally, with that, we are done with our cactus. Now we can play with all of our settings and see all the different combinations we can make. I hope you've enjoyed this tutorial. Thanks so much for watching, and I'll catch you in the next one. Bye!